Student friends, once again I welcome all of you to the online lecture of B.Sc. second year Analytical Chemistry. In last lecture we have learned about the semi-macro determination of nitrogen, hydrogen, carbon, sulfur and halogens in the first part. In the second part of this semi-macro determination of element in organic compound, we are going to estimate the functional group, that is nothing but functional group analysis. Let's begin with the functional group analysis. So what is the content of this today's lecture is that estimation of hydroxyl group, OH group, formerly from the phenol, and estimation of carbonyl group from the aldehydes and ketones. So see, in the estimation of hydroxyl group of OH group from the phenol, and what is done by means of the acetylation method, simple acylation reaction is there. So what is the principle for that? An accurately weighed known weight of organic compound is containing hydroxyl group is reflexed with an excess of acylation mixture, that is what acetic anhydride in pyridine, as well as that is acetic anhydride in pyridine. So after reflection, the hydrogen from the that what the OH from the hydrogen from the OH group of hydroxyl group is replaced by means of the acyl group, that is what RCOCH3, and another one is the acetic acid is side product. It is what the simply acylation reaction is there. So this is what the principle. After that, formation of this what ROH is reacts with that acetic anhydride CH3 C double bond O C double bond O CH3. Then one, that is what the this hydrogen is get replaced with this group, and will get the entire remaining product is what RCOCH3 acyl product, acylation, ester will get the ester, so and the side product is acid. So the excess of acetic acid anhydride left is then treated with the water, and when the following reaction is takes place. So excess unreacted acetic anhydride on hydrolysis with water will get the 2 molecules of acetic acid. So the total acetic acid form in both the reaction is then titrated with the standard solution of sodium hydroxide, that is what acid base neutralization reaction is there, and using phenolphthalein as an indicator. The volume of NaOH consumed in the main titration is main BR is treated as a ml. Means what first what will you have to do? Take a known quantity of the organic compound that contains OH group is what replaced with the acetic acid anhydride and pyridine. After that, a reflexation will get the ester and the acid. After the getting ester and acid, the acetic anhydride which is not reacted, that is left unreacted, is then treated with the water, that is means water is added to the solution, then we will get the hydrolysis of unreacted acetic anhydride into acetic acid. Then total acetic acid formed in both the reaction, that is first and second, is then titrated with the standard solution of sodium hydroxide by using phenolphthalein as an indicator. Simply it is what the neutralization reaction. The volume of NaOH consumed in the main titration, that is main BR, is treated as a AML. Then next, blank titration. First one is a sample titration. Then a blank experiment is performed using same volume of acylation mixture, that is acetic anhydride in pyridine, as that used for the main reaction, but without using the organic compound with OH group. Means what? Here what? The except the OH group, that is organic compound, nothing but sample, we carry out the titration by using same volume of anhydride, that is acetic anhydride in pyridine, and after that the entire acetic anhydride is taken for a blank, is treated with water, then the following reaction occurs. Means what? A similar what acetic anhydride gives the acetic acid after hydrolysis, then we will get two molecules of acetic acid, and this acetic acid formed is then blank is also titrated with a standard solution of sodium hydroxide using phenolphthalein as an indicator. The volume of NaOH consumed for the blank titration is blank Br is treated as a B. Means what? Here what we are using, in first case we are using the organic compound, that is what, containing OH group. This whatever the acetic anhydride taken is react with that OH group to gives what, acylation, and some amount of that acetic anhydride is what, left unreacted. This left unreacted acetic acid anhydride is treated with water and will get the two molecules of what, the acetic acid, but less amount of acetic acid formed in the first case, but more amount of acetic acid formed in the second case, that is in the blank titration, because there is no reaction between the organic hydroxyl group with acetic anhydride in the blank titration, because we are not using the organic compound, it is a blank titration. So we will get the greater reading, that is BML, for the second type of titration, that is blank titration. By making correction, that is what, the calculation from the blank and sample, we can able to determine the amount of that sodium hydroxide required to neutralize the acetic acid, and from this we can able to determine the amount of hydroxyl group present in the given compound. The acetic acid formed in the blank titration is also titrated with standard solution of sodium hydroxide using phenolphthalein as an indicator. The volume of NaOH consumed for the blank titration is, that is a blank Br, is treated as BML. The difference in the volume of NaOH consumed in blank titration and main titration, that is nothing but sample titration, blank Br and main Br, B minus A, is proportional to the difference in acetic acid formed in the blank and main, which is turns is proportional to the actual amount of acetic anhydride consumed by organic compound, and it is proportional to the amount of OH group in the organic compound. Means what? The difference in, that is B minus A, blank titration reading minus sample titration reading, whatever the difference is there, that is directly proportional to the what amount of acetic anhydride get consumed by the organic compound, and which is nothing but the amount of hydroxyl group present in the given organic compound. So we can relate this by means of B minus A, blank Br minus main Br, is directly proportional to the difference in the amount of acetic acid formed in blank and main, which is directly proportional to the actual amount of acetic anhydride consumed by the organic compound, and which is directly proportional to the amount of OH group in the the organic compound. So what is, it is the directly proportional. What is the difference between the volume consumed is directly proportional to the amount of OH group present in a given organic compound. Hence, from the difference in burette readings of blank and main, the percentage of OH group in the organic compound is calculated. So with the help of this formula, percentage of OH group is equal to B minus A into normality of NaOH into 70, that is nothing but the molecular weight of OH group, into 100 divided by weight of organic compound into 10. So example of organic compound containing OH group is a phenolic OH group. It is what? Phenol or carbonic acid. Then third one, the estimation of carbonyl group in the organic compound by oxime formation method. Here what? Second one is the what? The estimation of carbonyl group. So this is about the how to determine the carbonyl group in the given organic compound by enzyme formation method. So what is the principle for that? An accurately weighed organic compound, that is W gram, containing carbonyl group is what reflects with the sufficiently hydroxylamine hydrochloride reagent when the following reaction takes place. The carbonyl group reacts with hydroxylamine hydrochloride, then we'll get the enzyme. Here what the enzyme product is there, NOH. The amount of hydrochloric acid liberated in the above reaction is proportional to the amount of C double bond O group in the organic compound. Is whatever the amount of that enzyme is formed is directly proportional to the amount of carbonyl group present in the given organic compound. This is the what principle. Then the liberated hydrochloric acid HCl is then titrated potentiometrically against the standard solution of sodium hydroxide, that is NaOH, using a glass calomel electrode system. Then a graph of EMF versus volume of NaOH added is plotted to obtain the end point of titration. The volume of NaOH consumed by the hydrochloric acid liberated in the reaction, the volume is end point of the NaOH obtained from the graph, is proportional to the amount of HCl liberated, which in turns is proportional to the amount of carbonyl group is in the organic compound. So this is about the how this enzyme formation reaction is used, or method is used to identify or to estimate the amount of carbonyl group in the given organic compound. An accurately weighed organic compound W gram of containing carbonyl group is reflexed with the sufficiently hydroxylamine hydrochloride. Then reagent, then the following reaction occurs, that is what? RC double bond OR plus NH2OH HCl, that is nothing but hydroxylamine hydrochloride. Then this hydroxylamine hydrochloride reacts with this, that is carbonyl group, to gives side product water and HCl. So what happen? This NH2 is get condensed with this oxygen to get water plus what? HCl. So we'll get the RC double bond O N OH R dash. So this is what the enzyme. The amount of hydrochloric acid liberated, that is the hydrochloric acid liberated side product, is above reaction is proportional to the amount of carbonyl group in the organic compound. So whatever the HCl liberated is directly proportional to the amount of that carbonyl group present in the given organic compound. Then this liberated hydrochloric acid is then titrated potentiometrically against the standard solution of sodium hydroxide using a glass calomel electrode system. Then a graph of EMF versus volume of NaOH is plotted to obtain the end point of what the titration, and that is the volume of NaOH consumed by the hydrochloric acid HCl liberated in the reaction. So the volume, that is end point of volume of NaOH obtained from the graph, is proportional to the amount of HCl liberated, which is in turns proportional to the amount of carbonyl group in the organic compound. So in this way, that is relation is that what? The end point, that is by means of the potentiometry, the end point for the neutralization of hydrochloric acid by means of NaOH is whatever the burette reading for that is directly proportional to the amount of HCl liberated in the reaction, and which is in terms directly proportional to the amount of carbonyl group present in the organic compound. Hence the volume of NaOH consumed, that is Br, the percentage of C double bond O group in the organic compound, is calculated from the knowing the volume, that is what burette reading in the what titration, that is end point of the titration. By using this we can determine the percentage of carbonyl group present in the given organic compound by means of the formula percentage of carbonyl group, which is equal to volume of NaOH in ml into normality of NaOH into 28, and that is what the molecular weight of the carbonyl group into what 100 divided by weight of organic compound into 1000, that is what the whole solution. So example of organic compound containing carbonyl group is what dimethyl ketone or acetone or diethyl ketone or ethyl methyl ketone, ethyl propyl ketone. All these are examples of the organic compound containing carbonyl group. In this way we are able to determine or estimate the amount of carbonyl group present in a given compound. If you have any query regarding this topic, please put your question in the YouTube comment box. I will try to answer this question. So thank you. Thanks.